Okay, this is for an easy one. So you start off, and you just have your equation, and then you tell them that you need to write it as a perfect square trinomial. So it's got to be the binomial squared, so the same thing here. And we always want it to be x plus something, so they know I have to have plus x plus some number. And to make that happen, this middle number is always twice this number because it makes it happen twice. So they should know that when they're trying to make a perfect square, so this is what they're doing here. They're trying to have this length times this length be the same thing, because then that'll be that squared. And if you've ever had them do the box method before, they should know you'll get 4 terms, just like when you FOIL, just giving you the 4 terms. And so they know that this and this are the linear terms, and then it has to add to give you 4x and be the same thing. And this has to be the x squared. So this term always gives you the x squared term, and these are always linear, and this is always the constant. So, and you can, if they don't know that, you can give them examples of multiplying two binomials and seeing the patterns here that you get just when you FOIL. And so then they know that this has to be x and this has to be x, and in order for it to be a square, it has to have the same side length. So it has to be x, and these two numbers have to be the same. So that's why these two in here have to be the same, so that the number you pull out on both of them is the same. And then they can literally complete the square by finding out what fits in the last box. So 2 times 2 gives you the 4. So that what that tells them is that x plus 2 quantity squared is equal to x squared plus 4x plus 4. So tell them that you're trying to rewrite this in a different way, but if you write this, the only way it can be written as a perfect square trinomial is with this, because we have to deal with the 4x here. That's the only way you can get 4x in a perfect square trinomial. But it equals x squared plus 4x plus 4. You want to get down to 1, so that's why you have to subtract 3 in the end. So this would be your vertex form. And then I think this way is way easier to solve too, instead of quadratic formula, because now if you take that and set it equal to 0, you have a couple steps. Just add 3, and then x plus 2 quantity squared equals 3 square root. And then your final answer, subtract 2. Gosh dang it. Negative 2 plus or minus square root of 3. I think that's a whole lot quicker than negative 4 plus or minus square root of 4 squared minus 4 times 1 times 1 over 2 times 1, which is negative 4 plus or minus square root of, I'm going to skip here, square root of 12, or 2. Now I got to reduce the square root. Negative 4 plus, or I'm just going to do it quick, so 2 square root of 3 over 2, divide each by 2, and then you get negative 2 plus or minus square root of 3. So I think this method was way quicker than doing this way. Another way I taught my kids how to do the same exact thing, so I'll do that problem again, is to use the box still, and they still know that we have x squared has to go here, and so that has to be x and x, and then these two have to add to give you 4 and be the same thing, otherwise it's not a square. We still do that and get x plus 2, and then still have the 4 there, but then they want to change this to 4 then, so that they can factor it, because it's only factorable if there's a 4 in this spot, but there's only a 1. So then you would add 3 to both sides and get x squared plus 4x plus 4 equal to y plus 3. Then they recognize this is a perfect square trinomial, because that's like the biggest point here, is recognizing those. So they make it into 1, and then they can factor it to this. But then in the end, they need to solve for y again to put it in vertex form. So x plus 2 quantity squared minus 3 equals y. And again, this method might be even easier to do for solving a quadratic, because if this was 0, then you add 3 to both sides, then you just have 3, and then you're ready to square root there. So you don't want to add the 3 or subtract the 3 back. You you would just keep it at x plus 2 quantity squared equals 3, and then square root and solve from there. So this way of forcing it to be a perfect square trinomial by adding and just getting the perfect square trinomial on this side, everything else on this side, that helps more when you're solving for x-intercepts. And then they could even add another step in there. So there's just so many ways you can make them get rid of this first so that they'll ignore it. Because some of mine like to pay too much attention to this number when these are the only two that matter for finding this. So I would have them subtract it to this side first, then add 4, which is the actual completing of the square. That's another thing why it helped too, because they would want to know, why do I add 3 when completing the square is 4? So you want to add 4. So taking this over first would let them just add the number that they found to complete the square. So then you would have, if I would have subtracted first, if you would have subtracted first, you would have got x squared plus 4x equals y minus 1. And then since they're just adding what they found to complete the square, that's when they'll get this step right here. Because you'll get x squared plus 4x plus 4. And then that negative 1 plus 4 gives us that 3 there that they'll then subtract back to get x plus 2 quantity squared minus 3. So there's just so many variations, whatever makes sense to them, and whichever one you want to choose to teach them to. And then if it's not nice, we just do the same exact steps. I'll just do the first way I did it. So we want to make it be something squared, so it has to be x. The x squared goes here, so x and x. And then to be the same thing, these numbers need to be the same, which makes these numbers the same. So and they have to add to 3, so it has to be 1 1/2 and 1 1/2. Which makes these numbers 1 1/2 and 1 1/2. And this works the same if this is negative. I realize I didn't do an example like that. And then, but you know that. And then 1 1/2 squared would be 2.25. And then you don't want 2.25, you want 5, so you're going to have to add 2.75. So it'll be x plus 1 1/2 quantity squared, which gives you everything in the box, but you need a little more to get to 5. Otherwise, these two aren't equal. So that's why you add the 2.75 equal to y. And then that's vertex form. And then solving from there is the one that's actually going to be probably more complicated than a square root, or than using the quadratic formula, because like if that y is 0, so then you'll have this equals negative. First of all, it's going to be imaginary, obviously, but even if it wasn't imaginary, you'd have to have them convert this to a mixed number and then a improper fraction. So that'd be negative 11 fourths. Oh, but this one ends up actually being nice, because you don't have to rationalize the denominator. So it would be I squared of 11 over 2. But if it wasn't 4, if it was like 2 or something, the thing that's going to get them is having to rationalize the denominator. So then that's after we square root, so that would be x plus 1 1/2, so subtract to both sides. Negative 1 1/2 plus or minus I squared of 11 over 2, which, again, I don't know. I can't decide which method's easier. I mean, this one seems a lot of converting, because then you'll have to do that, because this is what you would have got with quadratic formula, right? So you would probably want to leave it as we usually leave it as just the one big thing, even though that's really not the complex number. They tell you to break it up into a plus bi, so that would be it would be square root of 11 over 2i. Yeah, that's just dumb. I like this method. I like that form way better than this form, but I don't know. So I just got your text message. Vertex form is easiest to write it in vertex form using completing the square. Hands down, anytime, always completing the square is always the best way to write it in vertex form. It's not always the best way to solve, just because of this example, because you have to do all this crap to get what you would get if you used quadratic formula. But to get vertex form, that's your guy. That's what you want to do. And one more example with a not equal to 1. So 2x squared, I'll even throw in an odd number So 2x squared plus 7x. So I'll make it really nasty. Plus, I'm not going to make this one nasty though, 4 equal to y. So then you tell them to make a 1. That's what I always tell them. Make a 1 if it's not. So it'd be x squared plus 3.5x plus 2 is equal to y over 2. And then, again, they're going to make their box and say, I need a square. So my x squared has to go here, so it has to be x and x. These two numbers have to be the same, and add to 3.5. So half of 3.5, 1.75. 1.75. So 1.75x, 1.75x. I can not do that in my head, so 1 second. Well, I can if I convert it to fractions. 49 sixteenths, right? Yeah, which is nasty, but whatever. 3.0625. And then you need to get to 2, so you need to subtract 1.0625. So it'll be x plus 1.75 quantity squared minus 1.0625 equal to y over 2. But then you got to remind them that they have to solve for y, not y over 2. So they got to multiply by 2. And what they're going to maybe have trouble with is remembering to distribute and to just leave it on the outside of this one. Some of them, usually it was the real low kids, wanted to give it to each of those. And then that times 2 would be 2.125 equal to y. So then your vertex, negative 1.75, negative 2.125. I think that's easier than make negative b over 2a and then having to plug it back into the quadratic. Because then if they have to plug it back in the quadratic, they have to deal with fractions. And mine usually, I like doing it by hand, and mine usually do it by hand too, or some of them will plug it into the calculator. So if they're just plugging it into the calculator, it doesn't really matter. But what they forget is parentheses. They always forget freaking parentheses when they have to square and stuff, so they always mess it up if it's negative. So I don't know. I like this version better. I hope that helps, and I think using a box once in a while helps, like especially when we're going to do synthetic division. Division of polynomials. Instead of teaching long division, I'm going to teach the box method. That's my long division method rather than actual long division, because that's super complicated for kids. So yeah, hopefully that helps.